Hello everyone, very good evening and welcome to the BYJU'S exam prep. This is Sanjay Rathi. How are you guys? Now it is a 2020 series for GATE 2024 and I'm going to deal 20 important numericals from network. So guys, how are you everyone? Kunal and all other students, please let me know that sound quality, picture quality, everything is fine. Yes, please. Everyone, everything is fine, na? Yes. Okay, very good evening everyone. Now I am going to solve some important yes, and there is a 9 p.m. session also where you will get the idea about the scribble pad. Okay, now this is a GATE 2024 T20 series network theory. Already you have solved some numericals from other topic. Now I am going to take network, and that is my introduction. Myself Sanjay Rathi, around 24 years of teaching experience. And I have trained more than 1 lakh students for competitive exams and these are my ranks in engineering services exam. बच्चे बताइए कितने लोग हैं जो engineering services exam देने वाले हैं on 18th of Feb. How many students are going to give the engineering services exam, guys? Sir, I want to learn only the EDC and analog. Okay. तो Jaydeep, for what? GATE 2025? Okay then. चलिए स्टार्ट करते हैं. तो दिस आर माय रैंक्स इन इंजीनियरिंग सर्विसेज एग्जाम एंड दैट दीज आर माय सब्जेक्ट्स. नाउ आफ्टर दैट I will upload the PDF of this session on electronics by Sanjay Rathi. If you want to ask some questions, if you want to get the notification about all other exams, right, post-gate guidance and so on, to join my Telegram channel, that is electronics by Sanjay Rathi. Okay, Jaydeep, you are for 2025. So I will give you the idea about that. I'm going to take sessions on EDC and analog on BYJU'S exam prep, full complete course. So before starting the session, by Richa Gupta ma'am, MTech from NIT Raipur, 5+ years of teaching experience, blueprint to Excel GATE 2025 in first attempt, right? Workshop on 7th Feb. Please note the date on 7th Feb at 7:30 p.m. and that is for what? GATE 2025, guys. Okay, so first of all attend this workshop, get the idea about that and ask your friend to join that session. Okay, already joined on 7th of Feb, na? Then, okay, already you have joined the BYJU'S. Okay, no problem. Now guys, everyone, tell me, that is the first question. What is the answer for this one? Obtain the Norton's current with respect to terminal A and B for the circuit. Circuit is visible to you? Circuit is visible to you? Okay guys, without any delay, we are going to solve some questions. So everyone, please give me the answer. What is the answer for this question? Tell me. Okay. Now, this is in a network. Remember, guys, electrical or electronics as well as instrumentation branch. Network is important subject. This weekend we have instrumentation, and after that on 11th we have electrical and electronics paper. So network. So network means what? Basics of the network. Then what? Just like KCL, KVL, simple source transformation, and I have taken number of sessions on those. Then what? Theorems. Okay, all theorems, especially what? Thevenin's, Norton, maximum power transfer theorem, superposition theorem, theoretical question. And after that, same theorem for what? Steady state analysis of sinusoidal signal, means for DC signal as well as AC signal. And then two-port network. Again, these are easy part. Okay, then what? Transient, first order transient, second order transient, but mostly question from first order transient. And after that, what? Mutual inductance, right? Dot convention and so on. Resonance, parallel resonance, series resonance. These are the important topics. Sometimes we are getting question from what? Graph theory, very basic questions on graph theory. Okay, that is not mentioned in the syllabus, but that is the part of basics. Now, to obtain the Nortons, the one student have given the C answer. Now we will check. We will check this. 1 minute. Okay then. Now watch this diagram. This is the 30 volt. This is the 12 ohm. this is 60 ohm and this is the 2Vx. What is the Vx here? Vx is the voltage across the 60 ohm resistor, and we have one dependent current source here, 2Vx. Now this is a 1 mark question only. 1 mark question. How it is a 1 mark question? For example, suppose it is short circuited. What is the Norton's current? Means what? Short circuit current. अच्छा, जिन्होंने ना नॉर्टन्स करंट निकाल लिया है, फाइंड द वैल्यू ऑफ RN, नॉर्टन्स रेजिस्टेंस और थेवेनिन्स रेजिस्टेंस फॉर सेम डायग्राम. नॉर्टन्स रेजिस्टेंस और थेवेनिन्स रेजिस्टेंस फॉर द सेम डायग्राम. टेल मी नाउ. जैसे दिस इज जस्ट वी हैव शॉर्ट सर्किटेड इट, तो शॉर्ट सर्किट करंट मींस व्हाट अबाउट दिस वैल्यू? दिस विल शॉर्ट सर्किटेड, तो Vx will become 0. So that Vx will become 0. This 2Vx will become 0. It will act as open circuit. So what is the current? 30/12. This is simple. This is the short circuit current, 30/12. Very, very easy question. That is given 2.5 ampere. That is the correct one. Okay. Now, so sometimes we are getting very, very easy questions, guys. Remember that. बहुत ज्यादा ऐसा नहीं है कि गेट में बहुत ज्यादा टफ आ जाएगा आपका और आपने पता चला लास्ट मोमेंट पे आपने सिली मिस्टेक्स कर दी. नाउ दैट इज द फर्स्ट वन. नाउ अगर आप थेवेनिन्स रेजिस्टेंस निकालना चाह रहे हैं तो व्हाट वी कैन डू. नाउ टेल मी व्हाट इज द वैल्यू ऑफ द RN. what is the value of RN? Okay then. Now this is 30 volt, it is given. When I want to find the RN, then 12, this is the 60. Okay, and this is the 2Vx. Now, what is the open circuit voltage? Because what is the RN? RN or RTH is equal to VOC upon ISC. So already you have the value of ISC 2.5. So what is the value of the VOC? VOC is nothing but Vx. VOC is nothing but Vx. This VOC is Vx. Okay. So this will become 2 VOC. Now you can write a KCL here. So VOC minus 30 by 12 plus VOC by 60. VOC by 60 plus 2 VOC. Can you find the VOC from this equation? Yes, we can find. You can take 60 as a LCM. Then 5 VOC minus 150. Check my calculation. VOC plus 120 VOC is equal to 0. This 60 will become 0. Then 127. Okay, 126 VOC is equal to what? 150. So what is the VOC is equal to 150 by 60. 150 by 126. Now you can put this value here and then you can find out RN. Okay, that is the approach. That is the approach. So you are getting the same answer 60 by, yes, you can check. You can put this value and you can find the value of RN. VOC we have, ISC we have, now you can find. That is the approach. Remember guys, when both ISC RN, VOC RTH, if it is asked, then you have to solve by this method. Is it everything is fine? Okay, then 1 minute. Okay. One minute. चलिए देखें. ठीक है सब. क्या हुआ भाई, ये थोड़ा सा डिले क्यों हो रहा है? यहाँ से तो सब कुछ प्रॉपर है. Okay then. Video is lagging, buffering. 1 minute. Audio good, video lagging. Give me 1 minute. No, Aditya. अगर if in a second method we have to short circuit that. हाँ, मैं पावर फैक्टर भी बता देता हूँ. No, audio is also lagging. Give me 1 minute only. Now working fine. No यार, बफरिंग अभी भी है. I think there is some problem. 1 minute. Okay. Hmm. Okay, I think now it is okay. Is it audible everyone? चलिए आप जरा सा कमेंट बता दीजिए मुझे सब कुछ सही है. Now fine. एक मिनट दीजिएगा जरा. Okay. Now watch this second type of questions, guys. Identify the elements that are passive in the figure. Passive in the figure means what? We have it is MSQ. First of all, read question carefully. There are two, right? First, this is plus, this is minus, this is voltage V and this is current I. So these both are positive. Current is positive, voltage is positive. So this is in first quadrant. This is in what? This is V, this is I, that is in first quadrant. Current is positive as well as voltage is positive. Now, this is plus, this is minus, this is I. So when we are choosing this type of polarity, then this is the voltage is also negative, current is also negative. That is what? Third quadrant. Voltage is negative, current is negative, third quadrant. In both the quadrant, if the line current and voltage lie in this quadrant and that quadrant, that is the passive. Passive means what? It will absorb the energy. It will absorb energy means what? This is the plus, this is minus. So current will enter through the plus, leave the minus. Current will enter through the plus, leave the minus. So both will lie in the first quadrant and what? Third quadrant. These are the passive elements. But if just change the polarity here, this is plus, this is minus, voltage same, but current is moving in opposite direction. Current enter through the minus, leaving the plus. Means current is negative, voltage is positive. So that is in fourth quadrant. That is in fourth quadrant and it will deliver the energy. It is an active element. Similarly, you are changing the polarity of the voltage but the current will remain same. So that is the fourth case. So then again it is an active element, guys. Okay, so active elements means what? In which quadrant? Watch this. This is the first quadrant, second, third, fourth. If the relation between voltage and current will lie in the second or fourth, means it is an active element. So it is active. Now watch this. B. It is only lie in what? First quadrant and third quadrant. Voltage, both voltage and current positive, voltage and current negative. That is a passive. It is lie in what? Second quadrant, fourth quadrant. Means it is active and this is the passive. First and third. What is the answer for this question? B and D. B and D. So power delivered or power absorbed. So power delivered or power absorbed means this one. I think now it is clear, Komal, Kunal. Fine, everything. Now, so Starvin Kumar Zinka. Okay, number of students have given the right answer. Now the third one. Identify the initial condition for the given graph. Identify the initial condition for the given graph, guys. Remember, okay, एक मिनट मुझे बताना सब कुछ सही है ना वो ऑडियो वीडियो. Okay. Now, when we are talking about the transient, there is a one important question, 1 mark question, 2 mark question from what? This topic, initial condition. I di by dt, d square I by dt square. So we will solve one 2 mark question also on this. Tell me, identify the initial condition for the given graph. Which one is the correct one for this particular graph? This is I, that is the time. This is I, that is the time. What is the value of I? What is the value of di by dt and what is the value of d square I by dt square? Right? Tell me which answer is correct. In initial condition, you have to find three things: I, di by dt and dv by dt, d square I by dt square, or v dv by dt or d square v by dv square and so on, d square v by dt square. So tell me. Okay, everyone, Aditya Raj, you have given the B answer. All other students. Now, watch this curve. Sometimes we have to draw the curve. We have different types of curve. Now watch this. This is like, okay, so what is the initial value of I? 0. What is the initial value of di by dt? 0. What is the rate of change? 0. Initial value is 0. But it has the slope. So d square I by dt square, it is not 0. Initially it is not 0. Otherwise it will not rise. All are 0 means what? It is a constant value. Okay. So that is the case. So B is the correct answer for this one. B. Now, but normally we are getting this type of curve. Exponentially increasing and exponentially decreasing. Okay. So that's why this is the case. Suppose we are getting the equation of the current across the inductor rising. Tell me guys, what is the initial value of the current? What is the initial rate? Right, di by dt, positive or negative? And what is the d square I by dt square? Right, what is the d square I by dt square? There are three options: 0, positive, negative. 0, so what is I? 0, positive, negative. What is the di by dt? Exactly at initial condition. Initial means 0 plus. Talking about the 0 plus. So these are the important questions. Tell me. Now, normally we are getting this type of curve, exponentially increasing function. Exponentially increasing function means what? This is the, yes, answer, correct answer for this question is B. Now, for this one, initial value of the current is what? 0. This is 0. Now it will increase. So what is the initial slope? Positive. So di by dt is k1 and k1 is greater than 0, positive value. K1 is what? Greater than 0, positive value. And then what is the value of d square I by dt square, everyone? This is important one. What is the value of d square I by dt square? Positive or negative? Now you can say, sir, what about the slope? Initially the slope is high. Now the slope is decreasing actually. Initially the slope is high and now the slope is decreasing. Means what is the rate of change of the slope? Negative. What is the rate of the change of the slope? Negative. That's why this is K2 less than 0. K2 less than 0. It is not 0. Okay. Negative. Initially it is started with negative. Now you can verify it. For example, what is the current through the inductor is given by V by R, initial current, e raised to 1 minus e raised to power minus t by tau. That is the formula, right? And for example, this is the RL circuit. So you can find, this is the voltage V. If the initial current is 0, then that will be the equation. Time constant is L by R. Now you can differentiate it and exactly at initial condition you can find the value. Put the I t is equal to 0, you will get, you can find a dIL by dt and you can verify it. Definitely you will get the negative value here. Differentiate it and then put the value t equal to 0. You will get the answer. Okay? Is it clear everyone? Now, अरे यार थोड़ा सा फिर से आप अपने फ्रेंड्स को बोल दीजिए वापस क्लास चालू हो गई है. ओके देन, कैसी चल रही है आप लोगों की प्रिपरेशन आफ्टर लॉन्ग टाइम? अभी मैं आप लोगों से मिला हूं और सब ज्वाइन कर लीजिएगा इलेक्ट्रॉनिक्स बाय संजय राठी. ओके ओके देन, नाउ नेक्स्ट वन. अब आते हैं जरा थोड़ा सा ये पूरा these are the two important topics. One is what RL circuit, one is what RC circuit. First order RL circuit, first order RC circuit. Electronics student, normally we are getting question from RC circuit, and electrical students we are getting question from RL circuit. So get the command over this. Now tell me what is the answer for this one. Determine the Thevenin's resistance and Thevenin's voltage for the given circuit. What is the Thevenin's resistance and Thevenin's voltage for this circuit? Quickly, it is a quick round guys, just like a mock test 2020. If you have any doubts, anyone, any problem, then please you can ask here. I will try to give the answer. Determine the Thevenin's resistance and the Thevenin's voltage for the given circuit. Tell me. सेकेंड ऑर्डर ट्रांजिएंट इज इम्पोर्टेंट नहीं इम्पोर्टेंट है नो प्रॉब्लम बट वी आर गेटिंग स्ट्रेट फॉरवर्ड क्वेश्चन नॉर्मली फ्रॉम स्ट्रेट फॉरवर्ड क्वेश्चन फ्रॉम सेकेंड ऑर्डर circuit over damped response under damped critically damped this type of questions you can practice. Now Thevenin's resistance, for example already we have solved one question but there is only there is an exceptional case, there is only dependent sources 10 ix. When there is only dependent sources and this is the ix, right? Now what is the open circuit voltage? So open circuit voltage is VOC. If you want to find the VOC, then what is the open circuit means? What is the current through the 1 ohm? 0. So that will become what? 2ix. That will become what? 2ix. Then the 2ix means what? 2ix. Okay. Now you can write down the KVL here. When I am writing the KVL, it will become minus 10ix. Minus 10ix plus 4ix plus 2ix. Is equal to 0. Then from this we are getting the ix is equal to 0. So is it possible to calculate voltage? No. Thevenin's voltage is not possible to determine because there is no active sources, active independent sources. So Thevenin's voltage is not possible, but in this case we can find the Thevenin's resistance. Thevenin's resistance simple, we have to make the active sources 0. There is no active independent sources. There is no active independent sources. So just like a scribble pad, you have to draw the again diagram. Quickly try to draw the diagram on your copy. And then there is only one dependent source. 4 to 1. 4 to 1. And this is ix. And this is 10 ix. Okay, this is the 4 to 1 ohm. Now, what is the method here? You have to connect what? 1 volt battery here. That this is externally 1 volt battery you can connect and this is the I. So 1 by I will give you the RTH. 1 by I will give you the RTH. Now, to find the value of I, find the value of what? 1 by I. Which one? Yes. No independent sources means Thevenin's voltage is 0. Okay, others. But you can find the Thevenin's resistance. So there is a one method. We have to connect the 1 volt battery and then what? We have to find the 1 by I. Okay, that is the Ix. Okay. So tell me what will be the answer. So this voltage will become 2Ix. Now write down the KCL at this point and find the 1 by I here. So that is the incoming current I. What are the outgoing current? Ix. What is the outgoing current? 2Ix minus 10Ix upon 4. Right. Now you can take 4 as LCM. This will become 4I. 4Ix plus 2Ix minus 10, 8Ix. Okay, and then you can solve the Ix is equal to minus I. Check my calculation. Ix is equal to minus IE. Okay, now what is the, this write down the KCL. 1 minus 2Ix upon 1. 1 minus 2Ix upon 1 is equal to what? I. Just I have written 1 minus 2Ix upon 1 is equal to I. Right. What is the Ix minus I? Is equal to I. Now it will become. Okay. Check my calculation and solve it. This is the minus I. That will become plus and this will become minus I. Minus minus plus. What is the 1 by I? Minus 1. So answer is minus 1 ohm. Answer is minus 1 ohm. Okay, that is the answer for this question. So negative value. Yes, you have given the right answer. So this is the C. Not possible to determine. Voltage is not possible to determine by the value of थेवेनिन रेजिस्टेंस इज नेगेटिव। तो सपोज अगर किसी एग्जाम में ना आपका अगर आने वाले अभी एग्जाम में अगर नेगेटिव वैल्यू आ जाए तो डोंट वरी, नेगेटिव वैल्यू भी आ सकती है, ये ध्यान रखिएगा। इज इट क्लियर? वी कैन फाइंड द नेगेटिव वैल्यू ऑल्सो। तो इसीलिए मैंने क्वेश्चन बताया, थोड़ा ध्यान दीजिएगा। वैसे भी देखो, व्हेन वी वांट टू फाइंड द थेवेनिन्स वोल्टेज और थेवेनिन्स रेजिस्टेंस, Thevenin's resistance, we have to make the independent active sources zero. So there is no independent active sources, then we have to apply what external battery of 1 volt or external current source of 1 ampere, and we have to find the 1 by I or V. Okay, so that is the answer. This is the C is the answer. Negative resistance means, what is the concept of negative resistance? Positive resistance absorb the power, a negative resistance deliver the power. I think that is clear to you all. So one, we have solved very simple question on Norton's theorem. Then now this is the questions on Thevenin's. So please revise this. Then next one. Okay, very simple question on maximum power. Negative RTH. Describe the presence of dependent source. No, that is not the case, Rajiv Kumar. Only dependent source we can say. Negative resistance, actually what is the significance of negative resistance? Means it will deliver energy. Means it will, suppose we are giving the energy E, then it will deliver the E2, that E2 will be greater than E. Okay, it will amplify the signal. That is the meaning of the negative resistance and so on. So minus 1 ohm is the answer. What was the answer for this question? Now the figure is shown, the maximum power delivered to RL is. Okay, Meghna, what is asked here? The question asked here is, what is the maximum power delivered to RL is? Not the value of the resistance. Only 1 mark question. Only 1 mark question. टेल मी नाउ। अरे बहुत ही सिंपल है। इट इज अ 2020 सीरीज। जल्दी जल्दी बताइए, अभी 15-20 क्वेश्चंस और बनाने हैं। इट इज अ 5th क्वेश्चन। कैसे आ रहे हैं आपके मॉक टेस्ट में मार्क्स? आर यू गिविंग मॉक टेस्ट? हो गया क्या लास्ट मॉक टेस्ट? भानु प्रकाश, यू हैव गिवन द बी आंसर। ओके, yes, if there is no independent, if there is a independent sources as well as dependent sources, then we can find RTH by connecting what 1 volt battery, and we have to make independent sources 0. एक्सपेक्टेशन से थोड़ा लेस आ रहा है। अरे नो प्रॉब्लम यार, आ जाएगा एग्जाम में, बी कॉन्फिडेंट। नाउ वॉच दिस। इन मैक्सिमम पावर ट्रांसफर थ्योरम, न्यू स्टूडेंट्स प्लीज वॉच। Actually, in maximum power transfer theorem, we have to find what VTH and RTH. For example, any network is given, and if this RL is variable, actually, this RL is variable. So according to maximum power transfer theorem, if suppose it is any network, you have to find the Thevenin's equivalent of this. First of all, this is the Thevenin's equivalent. This load is variable, this is fixed, RTH is fixed, VTH is fixed, this is variable. So what is the maximum power delivered to RL? That is the maximum power transfer theorem. In that case, RL should be equal to RTH. RL should be equal to RTH. Now, and the power given is what? VTH square by 4 RTH. VTH square by 4 RTH. This is the case when RL is variable. But if the RL is not variable, so that is the case, RL is fixed. Now, what is this? This is RTH actually. This is the RTH. So, for example, if the RTH is variable and you want what is the maximum power delivered to RL? What is the maximum power delivered to RL? But this is variable. How you can say this is a variable? Because R is not given. You can choose any value of R. Any value of R. In that case, guys, RTH should be equal to what? It is a passive resistance. So RTH should be equal to what? 0. So RTH 0 means this value of R should be equal to what? 0. So that is, when it is 0, finished. Now we have only VTH and RL. And what is the maximum power then? VTH square by RL. So 10 square by 2, that is the 50 watt is the answer. Very, very, very simple question, guys. Otherwise, in case of maximum power transfer theorem, you have to find the VTH, we have to find the RTH, you have to use the concept of Thevenin's voltage and Thevenin's resistance. And you can use these formula. And as you know, the efficiency is 50% only. In that case, efficiency is 50%. 50% power is delivered to RL, 50% power delivered to RTH. Okay then. Is it clear? The answer for this question is 50 watt. Again, this is of 1 mark only. 1 mark question. 1 mark. अपने मार्क्स भी ऐड करते जाओ भाई. कितने मार्क्स आ रहे हैं, आप कितना बना पा रहे हो, यस और नो, राइट और रॉन्ग आंसर. सेल्फ टेस्ट है ये. Now tell me, the number of independent KVL and KCL equation for a network with 9 nodes and 12 links are respectively. How many number of KVL and KCL equations? 9 nodes. बोलिए जरा. Theoretical question है. From the basics of the network. ऐसा हम लोग MSQ में भी देख सकते हैं भाई. There may be question on this MSQ. Number of independent KVL and KCL. देखो डायरेक्टली आपको तो नंबर ऑफ लिंक्स तो दे ही दिया है, राइट? D is the answer. अच्छा, आशीष कुमार रेस्पेक्टिवली लिखा है लास्ट में. रीड क्वेश्चन केयरफुली. रेस्पेक्टिवली. तो फर्स्ट व्हाट इज आस्क्ड? KVL इक्वेशन. देन व्हाट? KCL. KCL means what? Nodal equation. How many nodal equation is there? So nodal equation is n minus 1. So n minus 1, how many number of nodes? 9. So 9 minus 1, 8. So KCL is 8. So second option is 8. So in which we are having the second option 8 in only in 1C. Okay. And how many KVL equation? Number of links. Number of links is given by L is equal to B minus N plus 1. That is the equation. B is the number of total branches. N is the number of nodes plus that is the value. Are you getting my point everyone? This is clear to you? तो देखो छोटा इजी क्वेश्चन है, 1 मार्क क्वेश्चन, लेकिन ये MSQ बन के 2 मार्क्स हो सकता है. That is the 2 marks question. On basic of no, we have the command over the KCL and KVL, Kirchhoff voltage law, Kirchhoff current law. We can solve any type of questions on that. But this is a theoretical question. So that answer is what? C. So read question carefully. Kirchhoff voltage law, Kirchhoff current law. What is the number of nodes is given and so on respectively. and that is the formula. Okay then, next one. Okay, tell me. Now that is the question on two-port network. This is the port 1, this is the port and so on. Obtain the Y12 and Y21 for the circuit shown in the figure. Y12 and Y21 for the circuit shown in the figure. क्या होगा बोलो? What will be the answer? चलिए अपना टाइम दीजिए, 2 मिनट बनाइए जरा. अच्छा, from the options, is it a reciprocal network? Ashish, is it a reciprocal network or non-reciprocal? And then what are the Y12 and Y21? So Srishti or Nand Kishore, you have given the B option. Okay. Okay then. Now, so if the answer is B, so tell me, it is a reciprocal or non-reciprocal network? So, what is the condition for reciprocal network, guys? Now, one minute. Watch this. This is the diagram. This is the 3 ohm 6. One dependent source. देखो यहां ना आपको फिर से रीड्रॉ करना होगा डायग्राम, इसे जितनी तेजी से आप कर सकते हो उतना कर लीजिए. Then 3 and 6, and this is what I naught. V1 I1, V2 I2. Okay, so this is the value. You have to find the Y12 and Y21. So first of all, I1 is equal to Y11 V1 plus Y12 V2. Remember this. And I2 is equal to Y21 V1 plus Y22 V2. What is the Y12? Y12 is I1 upon V2 with V1 is equal to 0. With V1 is equal to 0. And what is the Y21? I2 upon V1 with V2 is equal to 0. With V2 is equal to 0, guys. So in one case we have to make the V1 0, in other case we have to make the V2 is equal to 0. Alright, I am fine. Meghna, how are you? Everyone, अभी अपना take care of your health everyone. Okay, अब ज़्यादा टाइम नहीं बचा है और थोड़ा सा वेदर कंडीशंस में भी थोड़ा चेंजेस है तो ध्यान रखिएगा। अब देखते हैं जरा। नाउ वॉच दिस, इफ सपोज आई वांट, फर्स्ट ऑफ ऑल वॉच द आंसर। नाउ वी हैव y12 is equal to what? Okay, there is a one problem that b and c are the same answer, no, I think. Okay, let it be, no problem. One answer is correct, so there is some printing mistake, I think. No problem. Now we will check. Now when just we want to find the this, you have to make the v1 0. When I am making the v1 0, you have to make it what? Short circuit. When I am making it what? Short circuit. For example, if it is short circuit, so what is the v1? 0 in first case. To short circuit, so what is the value of the I naught? v1 by 3. So v1 by 3 I naught will become 0. So when the v1 is 0, I naught is 0. I naught is 0 means this 2 I naught will act as what? Open circuit. These two I naught will act as what? Open circuit, guys. Now you have to find, this is the value, this is the short circuit because v1 is 0. This is the 6 ohm, this is the 2 ohm, and that is what? v2. Now you have to find I1 upon v2. This is I1. This is I1. What is the current through this branch? 0, and that's why you can make it what? Open circuit, but it is short circuit, remember. Now you can find V2 upon I2, or what is the V2 or I2? So V2 upon I2 or I2 upon V2 is equal to minus I1 upon V2. That is nothing but, right, you can 1 by 8, you can find that is the 1 by 8. And negative sign I1 upon V2, that is equal to minus 0.125. That is the answer. Minus 0.125 y12. Yes, is it clear? Okay, then that is the y12 value. Similarly, to find the y21, you have to make the v2 is equal to 0. When I am making the v2 0 means this is the short circuit. v2 will become 0, and you have to find the value of what? I2 upon v1, guys. Now I2 upon v1. So distribute it. For example, that is the current I2 here. You can write like this: 2 minus I naught, 2 I naught, and so on. Write down the KVL here, and then you can find. So what is the V? You have to find the V1. So V1 is this one. You will get the relation between what? I naught and V1. So what is the I naught is equal to V1 by 3. Now can you solve this? So that is the logic. In this way you can solve, right? So what is the answer you are getting? Yes, B. B is the answer. Now I have asked one question. Is it a reciprocal network or non-reciprocal? What is the condition for the reciprocal and non-reciprocal? What is the condition for the reciprocal and non-reciprocal? Y12 is equal to Y21. That is the condition. But what is the Y12 here? Minus 0.125. And what is the Y21 here? 0.375. Is it? They are equal? No. They are not equal, and that's why it is a non-reciprocal network. Non-reciprocal network. Very, very simple one. Right? So this is the case. Non-reciprocal network. Okay then. Next one. Next question. So अगर कोई problem है, if you find any difficulty, then please inform me. So that is the method. Or normally what pi network, when we want to solve, so sometimes we have to directly apply what? KCL at that point. KCL we can apply, and then we can find, guys. Okay. So for example, just I am giving you the hint. If you want to find, then you can put here V1, and that is what? V2 I2. So it will become V2 minus 2I2. V2 minus 2I2. This voltage. This is the V2, and that is the I2, V2 minus 2I2, and this is the 2I naught, and that's why this current will directly, you can find I2 minus 2I naught, 2I naught, and I naught will become V1 by 3. Why I am giving, you can directly write the KCL at this point, right? KCL at this point. What is the KCL? How we can write? What is the incoming current? I1. What are the outgoing current? V1 by 3, right? And now what is the outgoing current? V1 minus that, and so on. And then you can compare with this Y11 V1 plus Y12 V2, and then you can find the value. But only if the Y12 is required or Y21 is required, then that method may become what? Lengthy. Comparison के चक्कर में you have to arrange the equation, and that become what? Very lengthy. That's why this approach is more appropriate. Make one thing 0, take the condition and verify it. The answer, quickly you are going to get the answer. Okay, then tell me, before going to next question, that is guys, exam analysis, full electronics gate paper analysis just after the exam. To stay tuned with us, subscribe our channel, check out the answer keys and expected cutoff marks. We are going to solve each and every question just after the exam, right? But it is a memory based paper. जैसा जैसा आपको क्वेश्चन आएगा वैसा हम आपको इन्फॉर्म करते जाएंगे कि कैसा आप ये बनाया आपने पेपर, and what about the level of the question and what will be the cutoff marks, right? ये कब होगा? Just after the exam guys, on 11th of Feb, okay, for electronics branch. Now अब आते हैं next question में. So tell me, what is the answer for this one? What is the answer for this question? Yes, वो भी होगा राजेश, electrical as well as electronics. So first of all, go through all the conditions for electrical symmetry and all the conditions for what? Reciprocity, because we can get this type of questions as a part of what? MSQ. Achha, how many students want to solve some questions on MSQ? We are going to take one session on that just before exam. Multiple select question, series parallel connection of two-port network is shown in the figure. Okay, determine the Z22 parameter representation of the network. Z22. H parameters are given. For first network, H parameter is given. For second network, H parameter is given. You have to find the Z22 parameter. Okay. Nand Kishore have given the answer C. Please check your answer. Is it correct? Now, two networks are connected. At the input side, which type of connection? Everyone tell me. It is a series connection or parallel connection? It is a series connection or parallel connection. Watch this. Tell me which type of connection, guys? Series or parallel? बोलो कैसा है कनेक्शन? Okay then. Now here it is a series connection. And what is Z22? It is asked. What is asked here? Z22. What is the Z22 here? Z22 means you can write the equation like this. V1 is equal to Z11 I1 plus Z12 I2. And V2 is equal to Z21 I1 plus Z22 V2. Okay. Now we need what? V2. Z22. So what is the Z22? Z22 is, one minute, it is I2. So this will become V2 by I2 with I1 is equal to 0. V2 by I2 with I1 is equal to 0. Now, it is a series connection. So this voltage is what V1A. This voltage is what V2, right? V1B. This is the A network. This is the B network. So in a series, we are going to divide the voltage, but the current will remain same. Same current will enter I1. Same will leave I1. Same I1. Same I1. Now, here it is the I2. V2 is divided into two parts because it is a parallel. Watch this. V2 will remain same. This is V2. This is V2. Same voltage. V2, V2, V2. Now, this I2 is divided into what? Two currents. I2 is divided into two currents. The first current is I2A. Right? And same will leave the I2A and that is divided, or this current will become I2B. So I2 is equal to I2A, that is the enter into the network A. I2B means that will enter into the network B, guys. But the voltage will remain same. Okay. Now here I1 is 0. So what is the H parameter? Just I am going to give you the hint. For the first network you can write V1A H11 I1 because I1 will remain same plus H12, first one. H12 means what? 4. Okay. H11 means 25, 4. So I will write like this. First of all, I will write the equation V2. Right? V2A. This is A for network A. Similarly, you can write I2A is equal to H21 I1A plus H22 V2A. Now, for the first network, what is the V1A is equal to 25 times of I1 because I1 is same, so you can directly write I1 plus H12. What is the H12? 4. Four times of that value V2A. And V2 will remain V2 because V2A and V2B both are V2. I1A is equal to I2, I1B is equal to what? I1. Same. Right? So that is the same thing. Now, watch this. So what is the condition here? You have to make the I1 is equal to 0. So you will get one equation here, relation between that. Second equation, I2A is equal to, what is the H21? Minus 4 I1 plus, what is the H22? H22 is 1 Siemens. That's why it will become 1 V2. Right? And that is the two equations for the network number 1. For the network number 1. Similarly, for network 2, you can write V2A. Network 2 means network B. V1B is equal to 16 times of I1B. But I1B and I1A both are equal. So you can directly write I1 plus H12. What is the H12? 1 V2. Because V2B and V2B are same. So that is the equation. Similarly, then you will write I2B is equal to H21 minus 1 I1 plus H22 0.5. I will give you the shortcut, that is the V2. Okay, now we have the equation 1, 2 and so on, and finally we have to find what? Z22. What is the Z22? V2 by I2. with I1 is equal to 0. Overall current I1 and overall voltage. So that is the. So when I am making the from these two equation, first of all make the I1 is equal to 0. Right. Now when I am making the I1 is equal to 0, what is the I2A and I2B? When I2A and I2B is equal to what? I2. I2A plus I2B. So you directly you can add these two equations. Watch this. You can add the second equation and the fourth equation. So I2A plus I2B, it is nothing but I2 is equal to, what is the condition I1? I1 is 0. So no need to consider it. And when we are adding V2 and 1.5 V2, now you can find the value. Now you can find the value, guys. Check my calculation and that is the value. V2 by, we have to find the Z22, no? Yes. Z22, determine the Z22 parameter representation. So what finally what I am getting? 1 upon 1.5. What is the 1 upon 1.5, Nanda Kishore? What is the 1 upon 1.5, everyone? Tell me. Point 666. 0.666. तो give me comments, guys. बताओ सॉल्व करना है. देखो ऐसे क्वेश्चन थोड़ा सा वैरायटी ऑफ क्वेश्चंस है तो यू हैव टू सॉल्व इट. दिस इज कॉल्ड व्हाट? सीरीज कनेक्शन, where we have to divide the voltage. Here it is a parallel connection where we have to divide the currents. And I2A and I2B is equal to what? I2, because I am considering it as a network A, it is I am considering it as a network B. And then remember, yes, Asis. Now we have to write the equations, guys. Watch this quickly. If you are able to solve this equation, you have the idea about the H parameter. Directly you can write for the network A, then for the network B, and then apply the condition I1 is 0. Apply the second condition I2A plus I2B is equal to what? I2, and we have to find the V2 upon I2. So that is the question, and answer is what? 0.667. Again, try to solve this type of questions. Now this is the question from what? Actually it is the question from Van Valkenburg. Sometimes we are getting straightforward question from Van Valkenburg. That is the one book for network. Okay. Now तो अगर आप यहाँ भी अगर समझ में आ गया ना, more than sufficient, you can solve during exam. Now tell me, what is the answer for this one? Find the current I1 at t equal to 4 millisecond in the given figure. Where is the t? Watch this. Any problem, any doubt, then you can ask here. This is a 3. 1, 2, 3, 4, 5. Exactly at 4 millisecond. This is the 4 millisecond. Find the current I1. This is the I1. This is the capacitor where the current is Ix. This is the current source. Depend upon that 5 Ix. Ix is nothing but IC, and V1 is the voltage applied at this point. And that V1, the graph for the V1 is given here. First of all, find the exact value of V1 at 4. And what is the rate of change of V1 at 4 second? Okay. Just I have given you the hint. Tell me what is the answer. Take your time. This is the 9th question. Quickly try to solve this. Now, uh, exactly at 4, first of all, find the value of V1. Tell me what is the value of the V1, everyone? What is the value of V1 and what is the rate of change of V1 exactly at 4? 3 volt, okay? No, exactly at 4 second, 4 millisecond, what is the value? Now, I'm going to solve this question. First of all, watch this graph. Right, 1, 2, 3, 4, 5. Is it visible to you? Then what is the slope of this portion? This slope is negative. This slope is negative. So you can find the slope here. How we can find the slope? What is the change here from 3 to 0? So y2 minus y1, 0 minus 3, y2 0 minus 3 upon 5 minus 2. So this is the minus 1. Minus 1 volt per millisecond. Minus 1 volt per millisecond. That is the rate of change of the voltage. Okay. So what is the in a per volt per second? It will become minus 1000 volt per second. That is the rate of the change of the voltage at this point at the 4th millisecond. That is the rate, slope actually. Why we have find the slope? Because what is asked here, what is the value of I1 at t equal to 4 second? I1 is at t equal to 4 second. Now, when you want to write the I1 here, there you can write the KCL at this point. What is the KCL? Now you can write the KCL here. Watch this, how I am going to write the KCL. This is I1 is equal to 5. This is the incoming current is equal to outgoing current 5 milliampere plus Ix plus 5 Ix. So that is become total 6 Ix. Ix plus 5 Ix, that is the total 6 Ix. We have to find the I1. Now what is the Ix? Ix is nothing but current through the capacitor. Ix is nothing but the current through the capacitor. Ix is IC. And what is the IC? C dVc by dt. C dVc by dt. Vc means voltage across the capacitor is nothing but V1. This is the Vc to V1. So what is the dVc by dt? So this is the dV1 by dt exactly at t equal to what? 4 millisecond. So what is the value of the C? 2 microfarad. So 2 microfarad is the value. So you can write the 2 microfarad means what? 2 into 10 raised to power minus 6. And what is the dVc by dt? This dVc by dt is 1000. Minus 1000. So it will become minus 2 into 10 raised to power minus 3 ampere. That is minus 2 milliampere. So value of Ix is minus 2 milliampere. So you can put here, what is the I1 is equal to 5 minus 12. Because it will become 5 minus 12. So what is the answer here? Minus 7 milliampere. Minus 7 milliampere is the answer. Rajesh, Ashish, Sahil, Chinmay, everyone, that is clear to you? So what I have done from the graph you have to find the rate of change of the voltage across the capacitor so that you can find the current through the capacitor. And then no need to find the exact value of V1. The value of the V1 you have not given the answer, but value of V1 is 1 here. Because it is 3, it is 2, it is 1 and it is 0. You can find the slope and you can find the value. And finally, answer is minus 7 milliampere. This is the D is the answer. Any doubt? ओके जल्दी से बताइए फिर नेक्स्ट क्वेश्चन में एंटर करते हैं. यस आशीष, कोई डाउट है तो बताओ. क्लियर है कॉन्सेप्ट? क्लियर? ओके देन नेक्स्ट क्वेश्चन. चलिए बताइए. डिटरमाइन द करंट I1 इन द गिवन फिगर. So we can get the very basic question from what? KCL, KVL and basics of the network. Every year we are getting 1 mark question or 2 mark. Tell me. There is a one dependent source 5Vx, 8 kilo ohm, 4 kilo ohm, 2 kilo ohm resistor, and now you have to find the value of I1. Okay. ये तो कहाँ से आ गया सर? -1000। अच्छा, कौन सा -1000? चलो इसको स्क्रीनशॉट लो, बनाओ जरा। स्लोप बेटा, स्लोप ऑफ दिस लाइन, स्लोप ऑफ दिस लाइन, व्हाट इज द स्लोप ऑफ दिस लाइन? इट इज द नेगेटिव स्लोप ना। So actually what is the value at this point? 3, and what is the value here? 2, 3, 4, 5. 2, 3, 4 and 5. Exactly at 4th second, at this point it will decrease from 3 to 0. So what is the slope at this point? Change 5 minus 2. What is the change? -3, because it is a negative change. And what is the duration? Steps, 1 step, second, third. So it is what? -1 volt per millisecond. Why millisecond? This is the in millisecond. So what is the in volt per second? Volt per second means what? 1000 minus 1000 volt per second. हाँ, ये वाला this is of 2 marks. This is of 2 marks ना। ये तो है ना, इसमें थोड़ा सा लेंदी है, तो this is of 2 marks. Or it may be what? Numerical answer type. It may be of numerical answer type. Easy है, that is not tough. Very basic question. समझ में आ गया ना? ठीक है। And then find the current through the capacitor. Determine the current I1 in the given figure. I1 in the given figure. Just मैं देखो इसमें हिंट कर देता हूँ आप लोगों को. Now, what is the answer? Everyone tell me. Now, what is the voltage at this point? 12. That's why it is a 12 volt. Now from this point to this point it is 12 volt. According to voltage division rule, what is the voltage across the 2 kilo ohm? So you can find the Vx here. According to voltage division rule, 2 upon 2 plus 4 into 12. That will become 4 volt. So this is 4 volt. This is 8 volt. This is 4 volt, right? Or 12 divided by 6. So what is the current here? You can also find 12 divided by 6, 2 ampere. Easy. Now you have the value of the Vx. What is the value of Vx? 4 volt. So 5 into 4, 20 volt. 20. Now what is the current here? 12 minus 20 divided by 8. So -1. यही होगा ना current. 12 minus 20 minus 8 upon 8 -1. Now what is the I1 is equal to? Incoming is equal to outgoing current. 2 minus 1, that is the 1 ampere. What is the answer for this question, everyone? Is it correct calculation? Please check my calculation. Please check my calculation. कोई मिस्टेक तो नहीं है? ओके हाँ, कैलकुलेशन में हो गए तो मिस्टेक बता देना, अदरवाइज तो ठीक है। इजी। तो पैरेलल वोल्टेज, फर्स्ट ऑफ ऑल फाइंड द Vx, right? And then according to voltage division rule, and then guys from the voltage you can find the value of the dependent sources, then you can find the branch current, and then finally apply the KCL. Incoming is equal to sum of that currents. Okay then. Next one. Only 1 marks question. Determine the inductor current at t equal to 0 and time constant of the circuit for the given circuit. Normally for electrical branch they will ask what? This current. Determine the inductor current IT at t equal to 0 and time constant of the circuit for the given circuit in the figure. So when it is nothing is given, means exactly at t equal to 0, we are going to close the switch. We are going to close the switch. So what is the initial current at t equal to 0? Determine the inductor current at t equal to 0. Remember, inductor does not allow sudden change of what current. If the inductor does not allow sudden change of current, so first of all, just I want to give the hint about the circuit. Inductor does not allow sudden change of current. So always solve the question for T0 negative. So exactly at T0 negative, that switch was open. This is 25 volt. And inductor will act as what? Short circuit. Inductor will act as short circuit. This is the 3, this is the 2. So what is the current through the inductor? I0. I0 negative and I0 positive are same. That is given by 25 divided by 5 ampere. And inductor does not allow sudden change of current. Sir, actually the circuit was in the steady state before switch was closed. Yes, if nothing is mentioned means what? That is the before, determine the inductor, nothing is given means when the exactly at t equal to 0 switch is closed, means it is open for long time. When it is open for long time, circuit will be in steady state, inductor will act as short circuit because it is a DC. Now you can find, and now inductor does not allow sudden change of what? Current. Okay, 5 ampere is the answer. Now for t greater than 0, this switch is closed. Okay guys, tell me what is the time constant of the circuit? What is the time constant of the circuit, everyone? So time constant of the circuit, Aditya Raj has given 3.333. What is this 3.33? So just after t greater than 0, this is closed. So inductor will discharge through this path only. This path only the inductor will discharge. So what is the time constant? L by R. So what is the L4? What is the R2? So time constant is calculated for t greater than 0. So 4 by 2, this is the 2 second. This is what? 2 second. Okay. That is not the time. 1.25 you are giving. What is the 1.25? So R by L you are using. 3 plus 2, 5 by 4. No. Answer is L by R and you have to choose this portion. Now what is the third question here? Third question is, what is the current through this branch? What is the current through this branch? Any idea, any equation? Tell me. Suppose it is asked, what is the current through this branch? Then, if this is closed, what will be this inductor current? Inductor current will move like this, in this direction. And this will give one current I1. What is I1? 25 by 3. This is fixed because this is short circuited, this is 0. So 25 by 3, it is the I1. And that will enter here. If suppose it is asked, what is the value of the Ix? What is the value of the Ix? This is the branch current. So Ix will become I1 minus IL. Ix will become I1 minus IL. And what is the I1? That is the 25 by 3. Minus. What is the IL? What is the current through the inductor? The current through the inductor is given by initial current e raised to power minus t by tau. So what is the initial current? Already we have calculated. What was the initial current? 5. E raised to power minus t by 2. And that will become 0.5. And that is the answer. This is not the current through the inductor. That is not the current through the inductor. This is the current through this branch. For t greater than 0. Then this question will become of 2 marks. Are you getting my point, everyone? So that will be the question. What is the initial current through the inductor? What is the initial energy stored across the inductor? What is the equation of the current through the inductor? And what is the equation of the current through the short circuit path? Okay. Okay then. Finally, at steady state, what will happen? The inductor will lose its energy. And what is the energy across the inductor? 0. Then this path will work only. This path will work. Okay then. Next one. अच्छा, आप जल्दी जल्दी बताते जाइए क्या आंसर होगा. गिवन द सर्किट इन द फिगर ऑप्टेन, आप ये 2020 टाइप का चलेगा, जल्दी जल्दी बताना फास्ट. गिवन द सर्किट इन फिगर ऑप्टेन द नॉर्टन्स इक्विवेलेंट फ्रॉम ए टू बी टर्मिनल, ए बी टर्मिनल सॉरी. When we are watching from AB terminal, tell me what is the value of the Rn and what is the value of In. Rn and In. Vena Prakash, you are getting idea about the basic question. I am not taking just a tough question because it is an exam time, guys. Focus on the simple concepts. We are getting simple. Sometimes in rare cases we are getting extraordinary questions. अब ज़्यादा ना परेशान मत हो, बहुत ही लिमिटेड टाइम है हमारे पास. Already if you have given the mock test, then no need to give any mock test. Just take care of time management and so on. और कोई भी नई चीज़ भी पढ़ने की ज़रूरत नहीं है. हाँ, आप कितना क्विकली रिस्पॉन्स करते हैं, दैट इज वेरी इंपॉर्टेंट वन. ओके देन, व्हाट इज द आंसर फॉर दिस? ए इज द आंसर फॉर दिस क्वेश्चन, राइट. फर्स्ट ऑफ ऑल, very very easy one, because it is a 2 ohm, 7 ohm, 5 ohm, 9 ohm. So how we can find the Norton's resistance? First of all, make it what? Open circuit, make it short circuit. When I am making it open circuit, make it short circuit, then these 6 and 3 are in parallel. Next 6 and 3 are in parallel. This is the 4 ohm. And we have to find the resistance here. And this is the 2 ohm. So this is what? 6 and 3 are in parallel. What is the parallel combination of 6 and 3? 2. This is 4. Now these two are in series. This is A, this is B. Finally, you will get 4 parallel with 4. And what is the 4 parallel with the 4? Rn. Rn will become 4 parallel with 4. That is nothing but 2. So answer A, finished. If it is MSQ, if it is of 1 marks, please check the answer. Sometimes no need to find what ISC. Right. For this we have to redraw the circuit, or otherwise you can visualize it. Just to avoid the silly mistakes, you can redraw the circuit. The next one is, what is the short circuit current? Means what? You have to make it what? Short circuit. Watch this. Short circuit means make it short circuit. ISC. Okay. Or you can also find what? Open circuit voltage. Now you can use what? Source transformation. For example, 120 divided by 6. What is the 120 divided by 6? 20 ampere current. 6 and 3 are in parallel. That will become 2. So I am like, quickly I am going to solve this. This is in a parallel. So I can do what? 6 and 3 are in parallel. That will become 2. So I am getting the 20 parallel with the 2 ohm resistor. First of all 6, then 3, then this 6 and 3 will become 2, 20 parallel with the 2 ohm. Now you can convert it into a voltage source. 20 into 2, 40 volt, and 2 ohm in series. That is the complete this network. 126 and 3 is converted into 40 and 2 ohm. Okay. Now 40 and 2, and this is what? 6 into 2 12, and in series it is a 2 ohm. Now you can make a circuit. This is terminal A, this is terminal B. Now this is the 6 into 2 12, and that is 2. Now this is the short circuit path. What is the ISC? Right? Now you can find 40 minus 12 divided by 4. 40 minus 12 divided by 4, that is the 28 divided by 4, 7 ampere. That is the one way to solve the question. One way to solve the question. Is it clear? Source transformation, or you can directly make it what short circuit. You can directly apply the KCL and so on. You can find the value. You can find the value. There are number of ways to solve this type of questions, basic. Okay then, everyone. Next one. In the circuit shown, the current I naught in the ampere is. Current I naught in the ampere is. Now, sometimes we are getting very simple questions, but in exam hall we are making the silly mistakes. 4 क्या हो गया था? 4 आ गया था RTH. ओके 4 होगा ना RTH. RTH 4 क्यों होगा? Why RTH will be 4? अरे मैंने तो RTH निकाला ना, that is the 4 parallel with the 4, so that is the 2 ohm. Across the A and B, 4 parallel with the 4, that is the 2 ohm. Amanta Khanna, what is the doubt? You have to find the RTH across A and B. So you have to consider the remaining network parallel to 4 ohm resistor. Is it clear? No. In the circuit shown, the current I naught is. फिर भी कोई doubt है तो you can ask. In the circuit shown, the current I naught is. Now there are again number of ways to solve this question, right? Tell me what is the value. Redraw the circuit. एग्जाम से पहले ये ना बी कूल गाइज, कोई भी ज़्यादा वरी करने की ज़रूरत नहीं है. जो आपने तैयारी की हो सब काम आएगा. डोंट वरी, क्वेश्चंस बनेंगे आप लोगों से, इसलिए बहुत ज़्यादा हाई फाई क्वेश्चंस बनाने की आप कोशिश मत कीजिएगा, प्रैक्टिस मत करो उससे. तो देखो भाई, टोटल 100 क्वेश्चंस, 100 मार्क्स के क्वेश्चंस आने वाले हैं. गेट 22 कंप्लीट मॉक टेस्ट, ऑल MSQ क्वेश्चंस, ऑल MSQ, मल्टीपल सेलेक्ट क्वेश्चंस गाइस. ओके ऋषि जोशी, just you have prepared now 50%, so simply focus on the 50% syllabus, right? तो आपको मालूम है ना कि कैसा आपका प्रिपरेशन है, तो जो 50% सिलेबस है उस पर फोकस कीजिए और उससे उस पोर्शन से जितने भी क्वेश्चन आए उसको सॉल्व कीजिए फॉर गेट 2024। हो सकता है आपका लक साथ दे और आपके क्वेश्चंस पूरे बन जाए। इज इट? यस, कभी कभार होता है लेकिन हर बार नहीं होगा ना। एंड सिंपली फोकस ऑन द 50% सिलेबस ओनली एंड ट्राई टू सॉल्व ऑल दोस क्वेश्चंस। तो इन द सर्किट सोल्व, व्हाट इज द आंसर फॉर दिस? नो वन हैज गिवन द आंसर। तो ये टफ है क्या? ओके, देखिए जरा। Now this is the I naught. For example, this is the 60 volt battery. Try to understand. If the 60 volt battery is given the current I, for example, it will give the I. This is the I naught. So what is the current here? I minus I naught. Simple KCL. What is the incoming I? What is the outgoing I naught? So what is the current here? I minus I naught. This is 3 I naught. So this is the, we have to add. So it will become I plus 2 I naught. Is it clear? I plus 2 I naught. And what is the current here? It will become again I plus 3 I naught. Now here it is the 3 I naught is going here. This is the I. Finished. Now you can write a KVL. You can write a KVL to find the I naught. To write the KVL from this point to this point. I'm just giving you another exam in a simple method. Write down the KVL from this point to this point. Right. So when I am writing the KVL here, it will become 60 is equal to 4 times of I naught plus 8 times of I plus 3 I naught. Okay, finished. This is the one KVL and that will become 60 is equal to 4 plus 8 into 3, 24. 28 times of I naught plus 8 I. Now what is the relation between I and I naught? Write down the KVL in this loop. Write down the KVL in this loop, because with current source we can't write any KVL. 4 I naught, or here you can write 10 times of I minus I naught, 10 times of I minus I naught plus 2 times of I plus 2 I naught minus 4 I naught. Minus 4 I naught is equal to 0. Now it will become 10 plus 2, 12, minus 10 plus 4 minus 6 minus 10. Check my calculation. This is the 2 plus 2, 4 minus 6 minus 6 minus 4 minus 10 I naught, and this is the 10 plus 2, 10 I. So what is the I is equal to 10 by 12, that is the 6 by 5 by 6. Right here 5 by 6 in place of 8I and get the value. Tell me what is the answer. 60 is equal to 28 times of I naught plus, और भी easy भी method, don't worry, है ना. 8 into 5, 40 by 6 into what? I naught. चलो कैलकुलेशन करके बताओ कितना आ रहा है. व्हाट इज द आंसर फॉर दिस वन? बोलो जरा कितने आ रहे हैं भाई. आप ही सॉल्व करोगे ये. $1.73 we are getting. Yes, the answer for this question is 1.73. Answer for this question is 1.73. Okay then. Or you can apply also what? Mesh analysis, nodal analysis. There are number of ways to solve this question. There are number of ways to solve this question. Are you comfortable with this method? Just I have chosen these two equations, right? And I have arranged this and then got the relation between I and I naught finally, and put this value here, and then you can solve and you will get the I naught 1.73. Now MSQ1 theoretical question, tell me. Sir, when we can expect ISRO, ICRB? No idea, Gautam. Just I will collect information and then inform you. Select the correct statement. जल्दी जल्दी बताइए आप. Select the correct statement. Superposition theorem is not applicable to a network containing time varying resistor. In a reciprocity theorem, voltage and current remain same in all parts of the network. Thevenin's theorem is applicable to both linear and non-linear network. Millman's theorem yields equivalent voltage or current sources. तो कौन कौन से स्टेटमेंट सही हैं? तो यू कैन से सर मिलमैन थ्योरम इज नॉट इन द गेट एग्जाम, बट here already we have sometimes we are getting the questions on that. The first option is superposition theorem is not applicable to network containing time varying resistor. That statement is what? Right, because it is applicable for what? Linear network. So when we are connecting the time varying resistor means what? It will not satisfy the condition. Second one, in a reciprocity theorem, voltage and current remain same in all parts of network. Why it will remain same? Why it will remain same? That's why that statement is wrong. All part of network. What is the meaning of that? Thevenin's theorem is applicable to both linear and non-linear network. Yes, lumped parameter distribution, everywhere it is applicable. Millman's theorem yields equivalent voltage or current sources. Yes, with the help of Millman's theorem, we can get the single voltage source or single current source. So that is the correct one. So ACD is the answer for this one. ACD is the answer for this one. But acha, bolo bara. If we are getting this type of MSQ, then it will take time, yes or no? Be careful about that. If yes, you can mark because there is no negative mark. Because there is no negative marking. There is no negative marking, guys. Okay, take care of that. Now, this is just a large schedule for your mock test, guys. 65 question, 100 marks question on 100 marks, 180 minutes. All India Open Mega Mock Test for GATE 2024, Civil, Mechanical, Electrical, Electronics, Computer Science from 27th Jan towards 2nd of Feb. और आज ये अभी 2nd Feb. Okay, तो ये है, that is, and link is given in the description box if you have already given. Okay, otherwise that is the schedule for Electronics Engineering branch. You can note this schedule. तो enjoy किया आप लोगों ने test. Now next question, what is the answer for this one? The capacitor in the circuit as shown in the below initially charged to 12 volt with S1 and S2 open. S1 is closed at t equal to 0 while the S2 is closed at t equal to 3. S1 is closed at t equal to 0 and S2 is closed at 3. तो चलिए बताइए जरा. अब देखो, I am just giving you the hint in this question. What is the hint here? A capacitor allows the sudden change of current, but it does not allow sudden change of what? Voltage. So when we are talking about this question, capacitor in the circuit as shown below is initially charged to 12 volt with S1 and S2 both open. So it is a right. Now when we are closing the switch, guys, so which answer is correct? When we are closing the switch, initially it will give the current 12 by 3. 12 by 3, that is the 4 ampere current. Initial current is 4 ampere. In which diagram initial current is 4 ampere? A, C and what D? Means this is wrong. This is wrong. Initial current, right? Capacitor in the circuit, the capacitor current is represented by. So initial current is 4 ampere. Now what will happen? Once the capacitor will discharge, the current will reduce. So current will reduce. So here it is reducing. Now it will reach up to certain value. Up to what? 3 seconds. Then suddenly what we are doing? S2 is closed. Exactly at 3 seconds, the S2 is what? Closed. When the S2 is closed, resistance, 2 ohm resistance is short circuited. Now we have only 1 ohm resistor. And because of that 1 ohm resistor, suddenly the current will increase. Suddenly the current will increase. So here the current will suddenly increase at this point. And now again, the capacitor start discharging through what? 1 ohm resistor. Start discharging through the 1 ohm resistor, and finally it will become what? 0. Finally it will become what? 0. So what is the problem with this? 4 ampere resistance decreases, current also decreases. That's why it is not correct. Here there is a increase. This is wrong. This is decrease and again it will start increasing. No. because there is no active source, and that's why finally the current through the capacitor will be 0. Voltage across the capacitor will be 0. So that's why that answer is not correct, right? And this answer is not correct. Why? Because finally this is the constant current it is given, not possible constant current. So this is the correct one. You can also find the exact value, guys. You can also find, if you want the exact each and every value, this is the 4 ampere, then what is the value at this point? So you have to find the voltage across the capacitor exactly at 3 seconds. VC3 negative, VC3 positive. So first of all, the capacitor will discharge. You can write the equation. VC is equal to initial voltage 12 volt e raised to power minus t by tau. Tau will be RC. And what is the RC initially? 2 plus 1, 3 into 1. That is the 3 second. This equation is valid for 0 is less than t is less than what? 3 seconds. 0 is less than t is less than 3 seconds. So from exactly at 3 seconds, put the value here, put the time e raised to power minus 1, you can find the exact value of VC. Now when you have the exact value of VC, you can also find the exact value of what? IC. I3 negative is equal to VC at 3 negative upon 2 plus 1, 3 ohm. Now, but capacitor allow the sudden change of what? Current. So at this point there is a sudden change in the current. So what is the current at I3 positive? That will become VC3 positive upon, because it is short circuited. Therefore, what is the resistor here? 1 ohm only. And that equation is valid when this is short circuited. And this is valid for t greater than what? 3. So you can find the value, exact value, and finally this will become what? 0. That is the answer. That is the answer. And after that the time constant will become RC. What is the R this time? 1 only. And that is the C. जो भी C आपकी value है 1 farad, तो 1 farad you can use here. 1 second. देखिए ये ग्राफ है ना, तो that is the question. Now next one. हो गया ये भी क्लियर? या बीच में टेक्निकल इशू हो गया, पहले स्टार्टिंग में हो गया? बताइए जरा. दिस इज द स्टैंडर्ड क्वेश्चन गाइस. 5 times I have given the solution for this one. 5 times I have given the solution for this question. Tell me, what is the answer for this one? In the circuit given, the switch is closed at t equal to 0. The initial voltage on the capacitor are indicated in the diagram. The voltage and V2 for t greater than or equal to 0 are respectively. Now, for this question, exactly at t equal to 0, the switch is closed. Now, initial voltage is given. VC1 and VC2 values are given 0.5 microfarad, 0.5 microfarad. Okay. And that is given. Initial voltage 1 volt, VC2 is 0 volt. Initially it is charge 1 volt. It is charge 0 volt. Right? Then tell me which answer is correct. Now, this is a standard question, guys. In this question, law of conservation of charge is applicable. What is the law of conservation of charge? Initially, you can find the charge. V1, C1, 0. C1, V1, 0 plus C2, V2, 0. And that is equal to become the final charge. Exactly at finally what will happen? The voltage at this point and voltage at this point will become equal. And finally, the current in this branch will become 0. That is the situation at t equal to infinite. So what is the charge at infinity? Because the voltage is same, so it will become V infinite into C1 plus C2 V infinite. And now you can equate these two equations. When I am equating what is the final voltage across the capacitor, it is given by C1 V1 0 plus C2 V2 0 upon what? C1 plus C2. And that is the final voltage across the capacitors. So final voltage across the capacitor, you can put the value 0.5, 0.5, it will become 1 microfarad. 0.5 into what is the V1, 1 volt, and what is the V2, 0 volt. So 0.5 upon 1. So that is the 1 by 2. The final voltage is 1 by 2. Final voltage across both the capacitor is 1 by 2. So that is the 1 by 2, and that's why final voltage across both the capacitor is 1 by 2. Now, what is the time constant of this type of circuit? The time constant is given by R equivalent into C, or C equivalent into R. That is given by these two capacitors are in series. So 1 microfarad, because these two are in series. So 0.5 you can write C1 C2 upon C1 plus C2 into what? R. From this you can find the time constant. That is nothing but 0.25 into 4. 0.25 microfarad into 4 mega ohm, that will become 1 second. And now you can use the value Vc is equal to V initial, V final minus V final minus V initial e raised to power minus t by tau. From this equation you can find the voltage across both the capacitors. Voltage across both the capacitors, guys. What is the answer for this type of questions? So yes, you are getting the C. Okay then. तो चलिए आज के लिए इतना ही. मैं I want to give the some homework. Please note the homework on my Telegram channel. I will upload because already the premium session is started. So that is the one question. The switch in the figure has been closed for a long time. It is open at t equal to 0. Now guys, just practice this question. I am giving you the hint. That is the question from what standard textbook, study 2. Try to solve this question so that you will get the command over what? Initial condition. This is important one, B part. This is the important part, B part, and that is the homework for you. And then next one is, right, this is the first question. Please take a screenshot. Next question is on what? Resonance. Get all the condition of series resonance and parallel resonance. Theoretical. First of all, get the theory idea. For example, in series resonance, both inductor and capacitor will act as what? Short circuit. And then second thing, what is the impedance minimum? That's why the current is what? Maximum. That is the MSQ. Which of the following statement are correct? So that's why this is correct. The equivalent impedance is real. Yes, in resonance, imaginary part is 0. Impedance is real, only R. That is R. The inductive and capacitive reactances are equal in magnitude. Yes, XL is equal to what? XC. XL is equal to what? XC. That is also correct. Now, the equality factor equals to 1 by R C by L. You have to verify it. Quality factor is given by omega naught L by R. Omega naught L by R. And what is the omega naught? Omega naught is 1 by root over LC into what? L by R. So we are getting 1 by R root over L by C. Is it correct? No, it is not correct. So which answer are correct? A, B, C are correct. So that get the idea about what? Complete series resonance and what? Parallel resonance, because we can get good questions on what? MSQ. We are going to take one important session on MSQ. Then this is the question on next session we will cover. This is a question on what? Steady state analysis of sinusoidal signal. Steady state analysis of what? Sinusoidal signal, guys. Everyone, this is a very, very important question with phasor diagram. You can solve this question. It is important for both electrical and electronics students because it is a very, very simple question. You have to find the angle. कितने से lead करेगा? Inductor leads the voltage across the capacitor. So try to solve. I will give the solution on my Telegram channel. And then finally, last one, but not the least, mutual inductance. mutual inductance, you have to find only the coupling coefficient K. Only the coupling coefficient K. Two inductor have the self inductance of this one and that one, mutual inductance. The coefficient of coupling between, what is the coefficient of coupling? As you know, m upon root over L1, L2. Right now you can find the value of what? Coupling factor K. So this is the answer you can find, guys. Hope you have enjoyed the session. Please, already I have tried to cover the questions from all the part. If you have any difficulty, then you can inform me. So that is the leaderboard. You can attempt mock test here. Then guys, we are getting the sessions on GATE 2025 and 2026 with live classes, recorded lecture, study material, practice question and mock test. For more detail, you can call at this number, guys. This is the number here. Now, second important thing, get free one-to-one counseling and complete preparation guidance. बहुत लोगों को पता ही नहीं है गेट क्या है, गेट क्यों देना चाहिए, what are the advantages, कैसे प्रिपरेशन होगी, each and everything. So for one-to-one counseling, if it is required, then you can call at this number. Right? Fill the counseling form available in the description box. So description box में एक counseling form है, you can fill it. You can book your counseling. It is a one-to-one counseling, and without any hesitation, you can ask any type of questions related to what GATE and engineering services. Okay then, thank you very much for attending the session. This is my Telegram channel, Electronics by Sanjay Rathi. So like the session, share the link of this session, and most important, subscribe our channel, guys. क्योंकि अब हम लोग लेकर आ रहे हैं MSQ for you. Okay then, thank you and good night.